Hello everybody, this is Mrs. Snook with section 2.7 notes. And today we are going to graph the rational functions using the asymptotes, holes, and intercepts as guides. So we're just going to add on to what we did last time. Last time we found the asymptotes, the holes, and the x and y intercepts, and today we're going to use those as sketching guides. The process we're going to follow is factor both the numerator and the denominator, simplify if at all possible, and then you're going to find and sketch the vertical and horizontal asymptotes. Use dashed lines for those. And we're going to plot the x and the y intercepts, plot holes using open circles, and then we're going to get some extra points. We're going to need at least one point between and 1 point beyond each vertical asymptote. And once we have all of that, we can connect things with a nice smooth curve. So here's our first example. We're going to sketch the graph and accurately portray the asymptotes, holes, and the x and y intercepts. Everything else is going to be just a sketch, so it's not going to be perfect, but we will have the general shape. So first step, let's find the vertical asymptotes. The way we're going to do this is we're going to factor everything we can. Numerator I can't factor, but I can factor the denominator. I get x plus 2 and x minus 2. So asymptotes, that's where your denominator equals 0, and they can't cancel out. So that gives us x equals 2 and x equals negative 2. Let's go ahead and plot those asymptotes. I'm going to use red. So here's my asymptote at negative 2. Here's my next one at positive 2. All right, next thing, holes. Well, nothing canceled, so we don't have any holes. Next, horizontal asymptote. Look at the degree of your numerator and the degree of the denominator. Numerator is 0 degree, denominator is 2. So n equals 0, n equals 2. That means we have a horizontal asymptote on the x-axis at y equals 0. So I'm going to use red and I'm going to sketch that in as well. Okay, asymptotes are sketched. X-intercept. To find the x-intercept, you set the numerator equal to 0, but our numerator is 1. So we have no x-intercept. Y-intercept, set your x equal to 0. Okay, so for the y-intercept, I'm going to do 1 over 0 squared minus 4. I get a negative 1/4. So negative 1/4, right about there. So that's at the point x is 0. So y is negative 1/4. Let's look at that. I plotted positive 1/4. Let's try that again. I'm going to delete that. Negative 1/4 right about there. Domain, let's not worry about that. So now what I'm going to do is start sketching. And all I have is 1 point inside this one area. So snug up to the asymptote. Go through your point. I can't cross. I'm going to snug back up to the asymptote there. I need some points over here in this area. So I'm going to plot myself an XY table. And I am going to pick a point. Let's pick negative 3. Now I'm just going to plug in that negative 3. So 1 over negative 3 squared minus 4 gives me 1 over 9 minus 4. I get 1/5. So at negative 3, 1/5, so right about there. Now check that out. Snug up to the asymptotes. So snug, snug. I'm going to try, see how my curve actually bent away from the asymptote? That's no good. I want to get close to the asymptote. So something like this. All right, now I need a point over here somewhere. So I am going to pick, let's do 3. So I have 1 over 3 squared minus 4, which gives me 1 over 9 minus 4. I get another 1/5. But this time I'm at 3 1/5. So right about there. Snug to the asymptote. Go through the point you plotted and then head towards the asymptote. And try to make these curves as smooth as you can. So that's what this graph is going to look like. Let's do another one. First thing we're going to do is factor everything that we can. So x minus 4, x minus 6. Vertical asymptotes, that's where my denominator equals 0, and that's going to happen at 4 and 6. So I'm going to go ahead and put those in. So 4 and 6. Next thing, holes. Holes happen where we have things canceling out. Nothing does that, so I don't have any holes. Horizontal asymptote, the degree of my numerator equals 1, denominator equals 2, so therefore I have a horizontal asymptote at y equals 0. So I'm just going to sketch that in. X-intercept, so that's where your numerator equals 0. My numerator is just x. So check that out. I have an x-intercept right on an asymptote. So right there. And then y-intercept. We're going to plug in 0 for y. And when I do, I want to do that down here. Plug in 0 for x. So 0 over 0 minus 4 times 0 minus 6. That just gives me a 0. So I have and we're not going to worry about the domain. So the interesting thing about asymptotes is that's where you would go as you go further and further out. So even though we're on the asymptote at 0, that will still work. So now let's start figuring out our graph. So I need some points in here. So I am going to get a point, let's just use -1. So I'm going to set an xy table, put -1 in, and I get -1 over -1 minus 4 over -1 minus 5. That gives me 1 over 30. That's super close to 0. So I'm just going to go like that. Let's get a let's get a +1. So 1 over 1 minus 4 times 1 minus 5. I get 1 over 3 times 4, 12. So over here, it's a little bit higher. So this looks like it's doing something like this. Now let's go inside these two asymptotes. So I need a point in here. 5 is right there in the middle. I'm going to use 5. So I have 1 over 5 minus 4 times 5 minus 6. That's going to give me a -1. And right here, you get that. Okay. Let's do another one. This one is 3 over x minus 2. Vertical asymptote is just at x equals 2. nothing cancels, so there are no holes. And degree of my numerator is 0, denominator equals 1, so we have a y equals 0. X-intercept, that's where your numerator equals 0. That doesn't happen, so I don't have an x-intercept. Y-intercept, plug in 0 for x. So then y is going to be 3 over 0 minus 2. I get a negative 3 halves. So 0, negative 3 halves. We're not going to do domain. All right, let's plot our asymptotes. I have one at x equals 2. And then my horizontal asymptote is at y equals 0. And a y-intercept at 0, negative 3 halves. So 0, right there. Okay, let's get some points. So I need a point in there. I'm going to go ahead and just use 3. So x equals 3. Plug that in. I get 3 over 3 minus 2, which gives me a 3. So x is 3 minus 3. We have that. So through here, through there. So that's our first one. The other one, snug up to the asymptote, go through the point, snug up over to that asymptote. There we go. And let's do this last one. This will be our last one. Notice there's a lot of things we can factor here. I have an x plus 3 times x minus 3. And then I have an x minus 3 times x plus 1. Look at what cancels. Negative 3. X minus 3. So my vertical asymptote is only at x equals negative 1. I have a hole at 3. So we're going to plug in 3 to our equivalent expression, which is x plus 3 over x plus 1. And let's see what happens. So for the hole, 3 plus 3 over 3 plus 1, I get a 6 over 4. That reduces to 3 over 2. So I have a hole at x equals 3 and y is 3 halves. So 3 and 3 halves. Horizontal asymptote, numerator and denominator are both second degree. So our horizontal asymptote is going to be leading coefficient of the numerator is 1 over leading coefficient of denominator is also 1. So I get a y equals 1. So I'm going to put in the asymptotes. X is negative 1. And y equals 1. And then I have a hole at 3 3/2. So 3, 1 1/2. There's my hole. Oh, I missed. Let me try it again. There, that's better. I've got the hole right there. X-intercept. So where does my numerator equal 0? I'm going to take x plus 3. That's my numerator. Set that equal to 0. So x equals negative 3. So that means I have an x-intercept at negative 3, 0. So I'm going to go ahead and plot that. Y-intercept, that's where all of your x's equal 0. So I'm going to have a 0 plus 3 over 0 plus 1, and I get a 3. So my x-intercept is at 0, 3. So 0, sorry, y-intercept, I said x, 0, 1, 2, 3. I have a point there. So check this out, and domain we're not going to do. So check this out. Snug up to the asymptote, go through that point. We're going to go up to the hole, come out the other side, and snug up to the asymptote. That's what this one looks like. And then over here, snug up to the asymptote, go through your point, and then snug up to the other asymptote. So that's going to look like this. Let's make this curve look a little better. I want to try that again. Come out here and snug over there. There we go. That's what these graphs will look like. And that's it for today's video. Thank you for watching and have a fantastic day.